the volatile qualifier. The volatile qualifier in C tells the compiler that a variable's value may change in the way not explicitly specified by the program. This is crucial in scenarios where external factors like hardware devices, operating system subroutines, and concurrent processes like threading can alter variables' content without directly assigning the value in the code. By making a variable volatile, we can ensure that compiler always rereads value from the memory location and it does not optimize directly. Why such volatile matters? Due to compiler optimization. Most compiler assumes if a variable does not appear on the left-hand side of an assignment, it remains unchanged, such that it can optimize the code by catching the variable in register or reordering its evaluation due to external changes. In system programming, variable may be updated by the hardware such as timer, I/O devices, or other processes. Without volatile, the compiler might miss the changes because of optimization. Due to guarantee of the fresh reads. Declaring a variable as a volatile, it forces a compiler to access its memory location each time such that program sees the most up-to-date values. For example, system's date and time. Here, system's date and time may be updated by operating system's clock routine. Even if the program does not explicitly assign to system date and time, the compiler will always reread its value from the memory. Let's try to understand the things from the example. In this example, we have defined a global variable flag with value 0. In the main function, we have utilized a thread T. Thread T is running a function worker. In the worker thread, we are updating a global variable value flag to 1. At the same time, main function will continue to execute and enter into the while loop. While loop will be exited once the flag will be changed and our main function will be finished. It is important to note that flag is changed outside the main function in other thread. In the C, three types of optimizations are possible. O0 is indicating no optimization. O2 is indicating high optimization and O3 is indicating maximum optimization. Now let's try to update task.json file to optimize our code and see the results. Let's try to run with optimization 0. With optimization 0, the worker thread has updated the flag value. Now let's try to run with optimization 2 and see the output. It is important to note that with optimization 2, the another thread is not updating the global variable and our program is stuck inside the while loop. Let's stop the program and introduce a volatile keyword. Let's run. As you can see, when we introduced volatile qualifier, the flag is updated and our program behaved as per our requirement. Hence we can say that volatile is not allowing variable to optimize and compile for the further usage. And also note that due to another thread, the flag variable is changing. Because of the change, the volatile variable reads the flag value from its memory and get updated value. The same way, we can see other example for getting the time value from the subroutine. When we run the example, you can see the output is printing the time value from the internal system. Let's close the program and go back to the documentation and let's try to understand the further. Combining const and volatile. It is also possible to use both together to declare a variable, which means a variable cannot be modified by the program but still it can change due to external events. For example, a port points to a memory mapped hardware register at some address. The program cannot modify port directly as a const, but the value at the address may change due to external conditions. This combination prevents accidental side effect while ensuring the program always reads the latest value. The same example you can understand when you are connecting your hardware to the computer, such as keyboard, mouse, or a pen drive or hard disk. So key important notes: the volatile is essential in embedded systems, device hardwares, device drivers, and multi-threaded applications. It prevents dangerous compiler assumptions about variables stability. It is also essential to prevent overusing volatile as it reduces the performance, so choose the variable volatile carefully. From this section, we understand how volatile prevents compilation time optimization that assumes variables stability and order. Also recognized how to use volatile variable in multi-threaded application. And const volatile helps to handle hardware registers safely, such as memory mapped IOs, and also see the aspect to write safer, more reliable code in system programming context.